Hi folks, so in this video what we're going to be doing is a question from the 2011 Cert Dcg exam paper. It is the higher level 1 section B, and it's based on the topic of intersecting solids, or interpenetration some teachers call it. So what we have here, it says question B1, a 3D graphic of a trophy for an archery competition is shown on the right. The trophy consists of a number of intersecting solids. Solid 1 penetrating solid number 2. Figure B1 below, which is the elevation and plan, which is these guys here, shows the incomplete projections of two of these solids which penetrate one another. Okay, so you can see here we've got the elevation and plan. Part A, in the diagram, an irregular base pyramid, so it's a pyramid, okay, obviously comes up to an apex point, rests on the horizontal plane, means it sits on the ground. Draw the plan and elevation of this pyramid. So we start off by just drawing the pyramid. Now what do we look at so in relation to the pyramid? If we go in here and we look at the dimensions. In the elevation we've just been given the overall height, which is 80. We're not given the length, but if you come down here to the plan we can see that the overall length of the pyramid, which is this guy here, is 30 plus 30, it's 60 long. So therefore it's 30, so that's 30 there and 30 here and up to 80. So in drawing that then, and then we've got the width here, which is 80, and then the 30 and the 30. Okay, down 20 here, so it'll be the same to the other side. So we'll start off with that. Now, just before we actually started, sorry, I should have explained, when we're moving on, we're going to have to draw this little guy here, and we're going to be doing an auxiliary view down here. So where we're going to position our page is roughly up here in the kind of right-hand side of the middle. I wouldn't put it in the middle, I'd put it a little bit to the right of the middle. Plan down here, and then you'll have space here to do your auxiliary view. So, in regards to doing that then, starting off with an XY line, roughly about middle of the page, I'd say it'd be fine. Maybe a little bit below the middle. Okay. I'm going to do a line there, and I'm going to pick about, I think about there as a starting point, right there on my page. Okay. And I'm going to be drawing the object a little bit to the right of that. So, starting here as my start point, I'm going to measure then 30 and 30. 30 there, plus 30 there. I'm going to do a vertical line from the middle. The overall height is 80 as we determined, so 10 up as far as 18 is the 80. Should I get the measurement bang on now? And then drawing my elevation. And that is the elevation, okay, of the pyramid. Now from there, I'm going to project down to the plan. Could be any distance down. They don't specify a measurement between the XY line, okay, and the plan. So from there I'm going to measure down, doesn't matter, maybe 10 mil, and then measure down the width, which is 80 there. So I'm going to pick a distance roughly about there, do a line across like this, and I'm going to measure down 80 millimeters. Okay, so from there, with my T-square there, 80 millimeters. Make sure you're accurate in your measurements. I'm also going to, while I'm at it, I'm going to mark the 40 as well, because that's going to be the middle. So I've got my guy there. Now that I have the middle, I'm just going to mark that into there. Line goes across here, like that. And based on the drawing, this connects to here. This connects to here. So there is the first half of the plan. The next portion of it looks kind of like a hexagonal pyramid there, the other half of it. Okay, just zoom in here now a little bit better so we can see it a bit more on the screen. Measurement down here is 20, and it's going to be 20 at the other side. Okay, so on this line here, all I'm going to do is I'm going to measure down 20. And because the overall length is 80, if I go another 40, as far as the 60. And you'll see there where that measurement comes from. There's the 20, but there's the 40, and we would have 20 left over here. And now all I'm going to do from there then is connect this up, connect this, connect. That is the first part of our question done. Part A, draw the elevation and the plan. Now, in the next part, an equilateral triangular prism of 40 millimeter side, so two bits of information there. It is an equilateral triangular prism, which means here we can see it's an equilateral triangle, okay, of 40 millimeter side. That means all the side lengths are 40 mil all the way around. Equilateral triangle, all the sides same length, all angles the same. Penetrates the pyramid as shown, draw the outline, plan and elevation. So they're asking us here now to start putting in this bit of information here, but we can't put it all in till we find the penetration points. So we're going to start drawing this guy. Now, key bit of information here, from the apex, how far is it down to here? It is 22 millimeters. So I need to find that point, because that's kind of going to be my start point. I don't know where this point is, don't know where that is just yet, so I don't know the distance there. Okay, I don't know the distance out to here, but I do have this point, and that line is going up at an angle of 20 degrees. Okay, so finding that is the key bit there first of all. And then from that, we're going to go up here and we're going to draw in we're going to locate a point here and we're going to draw in our equilateral triangle. So, how do I do that? So on the elevation, from the very top, the apex, I'm going to measure down 22 millimeters. It's from the apex down as far as 22. Make a little mark there, do a line across. I'm going to continue that line because that will be used later on, but the point that's actually key to me that I found there is that point. Okay, so now that I've found that point, I'm going to use my protractor to measure an angle of 20 degrees. Make sure my protractor is the right way around. I like to use it with the T-square if I can. Bring it in, make sure it's sitting on the line, bring the center point of the protractor into the point there. Happy with that. Now I'm going to read around to 20 degrees. Apologies there. So all the way around, there's my 20 degree. Now that I've got my 20 degree line, I'm going to draw that in. I'll put it in over here to a certain extent. I'm going to draw it in over there like that. You can see here that it's kind of going off the screen. Now, I'm going to zoom out there a little bit because we're going to focus on the triangular section here now. So, in regards to getting the triangular portion up here, let's have a little discussion on that. What do I need to recognize? So I've got the line going out here. I don't know where to start this, but this guy can actually be started anywhere as long as it's not interfering with the object. So you have to kind of consider how far away I need to look at it, and you need to look at the sheet to see the proportion. So this is my start point. Okay, I can pick that start point anywhere along that line that I've just done. Okay, now what I need to look at here though is this line here. That's going right through the middle of the equilateral triangle. And if it's an equilateral triangle, that means that all the angles are 60 degrees, including this top one. But because this line is going through it, and that line is going to be perpendicular to the 20 degree line, it's actually going to split the angle of 60, which means that this half of it is 30, and this half is also 30. And then all the sides then are going to be 40 millimeters in length. So what do I need to do? First of all, if I zoom out there, I'm going to come out, I'm going to start maybe about here. That's going to be my start point. I'm just going to go right to the end of the line. I might actually go, just thinking here, I might go a little bit further. Put it a little closer to the end of the page, apologies. Go a little bit further, and I'm going to go maybe about there. So that's the point I'm going to use. So first of all, I need a perpendicular line. So the way I like to do it is I get my 45 degree set square, I put it on the 20 degree line, and I need to go perpendicular. So all I do is I rotate my set square, and now I'm perpendicular. There's the point I want to use. Do a line down like that. Now, I'm going to zoom in here on that point. I'm just going to move over the visualizer a little bit. I'm going to take my protractor and measure two angles of 30 degrees. Center point of the protractor sits at this point here, and then I'm going to make sure the 0 is resting on the line. So there we go. Happy with that. Set up correctly. 10, reading this way, 10, 20, 30. Just fitting on my page. Now that I have that, join it over to there, okay, and I'm going to do the exact same going out in the opposite direction. So once again, center point sitting on the apex, or the top point I should say. There we go. Set up accurately, reading around to 30 degrees. And as we said previously then, it is a 40 millimeter length, okay? So if you take your compass, mark as far as the 40 millimeters, 0 as far as the 4. You only need to mark the one side. I could mark 2, I'll show you here, I will mark the 2 of them. So technically, it'll join from here to here. And that's going to be my triangle. Now what's really helpful here though, is we'll see that the lines are going to run parallel. This line here is going to be parallel to the base. So it actually works out. If I just use sliding set squares now, because once I have one of them, just to show you, I will join them up. I'm just going to join them up by sliding set squares. So there's my 20-degree line that I'm using. I'm going to go down here and I'm going to go as far as either of these points, that one or that one. But you'll see that the 20-degree line actually goes through both of them. There we go. And now I'm going to continue it all the way down until it gets to the ground. So I may have to extend out my XY line a little bit. Okay, so extend out the XY line, go a little bit further. There we go. So that's my XY line, which I'm now going to start heavying in and make things a little bit clearer to us. So here is my XY line. And what we're going to do now is we're going to go up perpendicular from here, because they give us that little hint in the sheet, perpendicular. That'll help us find that top edge then. So, that's what we're going to do next. Just a lighting there. There we go. Now, so perpendicular to the 20 degrees, I can use the line that I've already got there. I'm going to rotate this guy. There, up as far as there. And out. And there we go. Now it's a case, what do I heavy in? So we'll start with the elevation. You're obviously looking at your sheet here, seeing what we're heavying in. And in regards to the elevation, so heavy in this line, from there over to there. And goes in as far as there, going as far as there. And pretty sure this is heavy the whole way, based on the sheet. And in regards to this one then, go heavy down to there, or just heavy as far as there, go over this guy a little bit. Okay, and down here now as well. Okay, so there we have our elevation. Now what we're going to do is we're going to start putting in our plan. Now I'm not going to heavy in that bit there because it is penetrating into the object a little bit, and I'll have to work on that later when I do my auxiliary. What I will also do up here though is heavy in the triangle. And there's different methods that you can use to complete these questions. I like the auxiliary method, maybe slightly longer, but because we're so used to doing auxiliaries, lots of students kind of like that method. So, in regards to the plan now, if we look at the plan, you can see here it's 40 wide, okay, and that's kind of coming from our 40 base here, because as we look down on top of it, we can obviously see the kind of width of it. So there's the 40, and it's touching here and here. So that's the points then that I'm going to do my horizontal lines. I also have a center line, so half of 40 is 20, and that'll help me locate this, and it'll actually help me locate that as well. So, from these 2 points here, I'm just going to go out to the right, and then also go through it to the left. Okay, now that I've done that, I'm going to project from the elevation down to there, down to there, from here, down. Now, I'm also going to measure, as I said, 20. So we can see here that we have 40 millimeters. I'm going to mark the middle, which would be 20, just do a line across. Now that's going to help us heavy in some information. So look at my sheet as a guide. When I look down top of it, I have an edge here. That's the triangular, because that's a triangular face at the back of it. So you want to see the triangle. And as we look down on top of it, this edge on the ground is actually hidden. That's hidden detail there. So there's my hidden detail. I'm just going to heavy it in as far as here. Okay, not exactly sure how far that goes in just yet. We can figure it out fairly quickly. I'm just going to heavy in that much. Then we'll get into explanation. I always like to just go in with the outlines first. So there we go. Apologies there guys, just getting a quick phone call. So now that I've got that, what I'm going to do now, looking at the picture, can I find this point here? Yes, I can. It comes here from this point up here in the elevation. So I can actually find that, and it's going to be right in the middle, because that's where that point is hitting the face. Okay? and bring that down. That's a really helpful point for me there straight away in the middle of it. So now that I can do that, heavy in this much. Heavy in this much. Okay. And I'm going to heavy in as far as here. Just looking at the sheet for my guidance. Okay. Now from there, start heavying in these bits on the outside. Bits on the outside. Now, in regards to what I heavy in up here, I'm going to leave that because the object is penetrating into it. Okay, so there we have it, guys. That there is our elevation, and our plan. Okay, completed. And we've after been putting in, we just put in our equilateral triangular prism that is penetrating through it. So, what we're going to do now is we're going to find those penetration points. Now, really, really easy ones for us to actually find is this face here. Now, what's helpful about this face here is the back face here of the object is actually an edge view in elevation. Why is it an edge view? Because the baseline here, the line that's on the ground, is a true length, and as I look along a true length, I'm seeing the true length as a point view, and I'm going to see the surface then as an edge view, because we know a principle, if you look along a true length and you see it as a point view, the surface that it's actually on will be seen as an edge view. And what's helpful about that edge view is we can actually identify the intersection points on that face. So in that one there, we don't even need the auxiliary. Okay, so what can I do to find those points in the plan? Simply a case of projecting them down. There's one cut point for the bottom edge. So this is what I was saying, I wasn't sure how far they go in. And there's the cut point for the top edge. So the back face is actually quite a nice little easy one in this question. And I'm after finding, that's the top edge which is in the middle. And there's my bottom edges, there and there. So this is actually how far it will go in as. From there to there. There to there. And now, I can heavy this up here. And here. So now that I've got that, how do I complete the rest of it? I need to put in hidden detail. And there'll be a hidden edge there. And don't forget the edge that's actually underneath the object, the one that's on the ground. That will also go in as hidden detail. Okay, so that's the left hand side of it actually taken care of there without having to do any work. And we also had actually found a point up here. Now what I usually like to do is number. Okay, so let's take these as the numbers. All right, I'm just going to number my triangle. I'm going to say 1, 2, and 3. So there's my numbers. Now, how do I represent those numbers? Number 1 is at the very, very top, and that's the one in the middle. So it makes sense that actually 1 is here. You could number it out here as well. And the question then is, which one is 2 and which one is 3? Now, how would I determine that? Now, the way to actually do that, I'm going off the question here a little bit, but I'm going to use my line here as a guide. You can see here, I'm just going to pull it down. So I'm using that as a guide. Sliding set squares here. We need to bring it down a little bit further, apologies. Visualize it in the way there. I'm going to use this as a guide. So from 3, I'm going to come down. From 2, I'm going to come down. Then I'm just going to rotate. Okay, and what I'm actually doing here is I'm going to take the measurements. Okay, so my very first measurement, that's 3 to 1 to 2. Okay, so then, because this one is the one that actually starts at the front, that is 3. The distance from there to there is the distance from there to there, and then the distance from 3 to 2 is the distance from 3 to 2. So there's number 2 on that side. Okay, just so we're aware of that. So there's 3, 1, 2. Now what we're going to do to find our intersection points is we're going to create an auxiliary view. Okay, so I'm just going to pull this over here to the left a little bit now. You can see that there. And what we're going to do is an auxiliary view. Now if you have an adjustable set square, this is much easier, but I'm just going to work with what I think most students would have, and they mightn't always have an adjustable set square. So I'm going to use the sliding set squares. So I'm projecting and I'm looking down at the object to see where it's penetrating through it at a 20-degree angle. So all I'm going to do, easiest thing to do here is I'll actually extend, and I'm going to get the triangle first and build the object around that. So I'm going to go like this, and then use sliding set squares, go up here to the top one, 20 degrees, and we're going to set up an auxiliary view perpendicular to that. So you can see how I rotated my set square there. And I'm going to set it up just about here now. It's going to come down here. So I'm going to come out a little bit actually. Come down to about there, I think. Now, I think that's more appropriate. That there becomes my x1, y1. Now, I projected out my points. That technically up here, if I was to label that, 1 is this point here. That's the edge for 1 running down, and 2, 3 is here. Okay, so I'm projecting down. So I projected down 1 and 2, but while I'm at it, I'm going to project down all the other points that I'm going to need. There's a point. There are my points on the base. And then don't forget the apex. The apex is up here. And there we go. Now, they've all projected down, and we've set up our auxiliary view. This is an auxiliary plan because we project from the elevation, but we're taking our distances from the XY line down the plan. Okay? So this is technically an auxiliary plan. Now, if I was to label the object, okay, if I was to label it, I've already labelled the triangle. I'm going to label the pyramid with letters. Okay, I've gone with numbers for the triangle, so I'm going to use letters. So I'm going to say the apex anyway, first of all. I'm just going to say that's O. So there's O. Now on the ground then, I'm going to start here. Doesn't really matter where you start. I'll actually start here. There's A. It goes up here to this point here, B. Okay, we've got a point here, C, D, E, and F. So I've got 6 points. A, B, just checking, yeah, because A connects up to O, B connects up to O, C, D, E, and F. Now if I was to label them, A and B would be here, so it goes A, comma, B. What's here? It's F, comma, C. I see F first before I see C. C is at the back. And then E, comma, D. And that's my labels. Now I want to find all of those. So let's start building the object. As I said, I'm going to take the triangle first. So I take the distance from the XY line down. To be accurate here. XY line down as far as 3. Follow 3 out. Mark from the X1, Y1. There's my mark. Hard to see it there. Now I'm going to take the distance down as far as 1. And mark it as far as 1. Take the distance down as far as 2. And mark the distance. Follow 2 down. And there we go. And what you end up what you should end up having here is your triangle again. So this is the furthest distance. So I'm going to call it 2, 1 and 3, 1. Because we're on the X1, Y1, I just label it those based on that. So let's heavy it in. So I do see that entirely. Working my way through it now. So there's my equilateral triangle. Now let's start building the rest of them. So I'm going to start with A. There's A. XY line down as far as A. There's my distance taken. Now A is also the same distance as F, so I'll do both A and F. So I follow A out, mark it off. Let's find F. F is here. Okay, I've got A and F done. Now I'm going to do B and C. There's B. It's followed out. And then C. On the same line. The next one I'm going to do is D. There's D. Just make sure. Got the right measurement. Yes. Follow it out. There's D. And finally T. And mark E out here. And I have one final one. The apex. XY line down as far as O. And go up to the apex. Follow it out to the X1, Y1. There's O. Now, that's some of the hard stuff done. So there is A1, and I had F1, I have B1, C1, D1, E1, and O. Now let's join it all up. Okay, I'm going to join it in lightly first, and I know every one of these connects to each other. So A connects to B, it's already a line. B connects to C. C connects to D. D connects to E, it's already there. D to F, or E to F, sorry. And F back to A. That's my base. Now, every one of them connects up to the apex O. So A to O. F to O. E to O, D to O, C, and B. Now, remember, we're looking in this direction at it. So which face can we see? I can see the face EDO. It's like we're looking in this direction. This direction up here in elevation, it's kind of like here in plan, kind of going in at an angle, but I can see that face EDO. The face that's actually at the back is the face ABO. Okay, so this will kind of inform me in what goes in as hidden detail. So the outline, I'll actually see all these lines here, I think. Yeah. Now this one here is one of the ones that's important. This is one of the ones where we have a penetration. That's where the solid is penetrating, so I'm not going to heavy in as far as there. I think it's the exact same with this one. There's our penetration. Okay, and then we get onto this guy. Now, drawing that, draw that, work our way around the object, and just remember, don't forget any hidden detail. This is an orthographic drawing, so you have an edge here at the back from A to B, going all the way through. And there we go. So there is our auxiliary view. Okay, that is an auxiliary plan. But what's important about that is it's highlighting to me the intersection points of where it's cutting through the faces and those points that I need to find. Now I'm using markers here. More than likely, I'm guessing, because the object, this one here probably should have been in line with that one. Now I'm using a marker, so it's probably there. You could debate, is it there? So I'm kind of around the right range, but I have a little bit of inaccuracy there. So what we're going to do is we're going to find those intersection points of where it's penetrating through the front face. So edge 3, I want to find where that goes through into the front face. So I've got lots of penetration points here. Let's find them. If I was to start at number 1, that's 1 already. So there's 1. I like to use just a little yellow highlighter here. So have I actually got that one already? Yes, I have. That was that point there, which I've also found in the plan. So that's done. The next penetration point is on the edge here. So it goes around, okay. Some people call them turning points from O. So where is that point? It's on the edge from O connected to D. Okay, what one does that join to then? That joins to number 3. Now 3 is a little bit different. That's one of the ones we'll have to figure out. How do I find 3? That's on the face connecting O to D to C. So we're going to have to get clever there and creative. Then from 3, it's going to connect to this point. Once again, that point is easy enough to find because that is on the edge from O to D. It's probably just going to end up hitting right there. Same with this one. We go over to here. It kind of works around in the clock. You can see it there. Now that one's on the edge from O to E. 2 is the next one. 2 is on the face from O to F to E. And then finally up to here, this point there is once again on the edge from O to E. And then we bring it home back to 1. So there's all the intersection points we have to find. Okay? How am I going to find them? Well, I've already found this one, so that's fine. How would I find this one? Well, that's on the edge connecting from O to D. Okay? But I want to find exactly where it is. So I have to do sliding set squares projecting back to my views using the 20-degree angle. So let's find them. From here, it's going to work backwards 20 degrees. Okay? Now this is where my little bit of inaccuracy is after kind of coming in. It probably should have been down there, so apologies for that. So I'm going to take it just a little bit higher. It's probably a little bit inaccurate. So as I said, I want to find those intersection points. So as I projected back, it's on the edge from O down to D1. So where is that? O to D is this line here. So I'm after finding it. Where it comes back and it hits that line, I'm after finding that. Okay, now what we have to understand is in the elevation, it's like I'm standing over here looking in this direction. So the only side in the face that I can see is the edges going down here. Any edge here, if you look at the arrow, is behind this face here. So I can't see this face. So that's a little hint there. If you can't see the face, from 1 down to this point, if I was to draw it in up here, how do I draw it in? It would actually have to go in as hidden detail. So that's my very first point. Okay, so I like to take it one at a time so I know exactly where I'm going with this. So I found that point there. That's the very, very first one I'm after finding. That one now connects to number 3. So how do I do number 3? I need to do what's called an element line. So from the apex, I'm going to do a line from the apex through 3 down to the ground. and it's going to hit the ground at the edge where D and C is, and it's going to hit right there. So now that I've got my element, okay, I'll actually put it in with a little colour here, just for the very first one. I'll put it in with the red. So it's like I've gone with an element line until it hits there. Okay, now I need to work that backwards. I usually obviously be using pencils here, but just for demonstration on this one, I will put it in red. So that's after projecting back there. Trying to do it neat and tidy. And it hits right here. So that's the point there on the ground. What does it connect up to? It connects up to O, the apex. And I draw it in. Now, that's my element line. I'm just going to do this, a couple of them, nice and light, because I don't want to ruin the drawing. You can see it kind of in there. But what one is that cutting through? It's cutting through the line 3. And if we follow 3 down, see the element line that goes up? Where it intersects right there. That there is my point. Now I've found the point. So what do I do with that? Once again, it's behind. Remember I said it's behind the face? So that goes in as hidden detail. And it connects up to the previous point which we had up here. So all I do is join the line down. I just go like this. Okay. Now, what's good about number 3 is that edge is going all the way in. That's kind of at the back. Now, I think I'll have hidden detail. I'll probably be heavying in that in a second. I'm just going to start working my way around it. So we've got 3. How do I find this point? That point is on the edge from O to D. But you'll see, look, that one is already actually gone back. So it's actually right there. Okay? So that's kind of already done for us. Now, what about this point is the next one. So we've got this point, it's right there. What about this point? That point is on the edge from O to E. But if you follow it back, once again, O to E is here. So it's also right there. And the next one then, is from the edge from number 2. Okay? So what we have here, as I said there, we got this point here. That's already been found. It's right here. It's actually found for us. The next one we need to find is number 2. So how do I do that? The exact same way as I did number 3. If the object is symmetrical, it should finish on this line as well. So we'll see how we're doing here. Okay, and obviously this has a lot to do with the thickness of the pencil. So I'm doing an elements line down through 2 and recognize it's on the face from O to F to E. So, slide and set squares. Bring that back. We'll see what I'm looking like here. That one's not too bad, so I'll try and make it join up there. There you go. So there's my element line. I'm going to use the exact same one. And number 2 is going to end up finishing in the exact same place. So now we've got over here, this is number 2. Okay. And that's where 2 is going to go heavy in. So that's why I was saying here, I think this line, as I said previously, that's actually going to end up in a heavy line. Now, 2 goes up as far as here, which is on the edge from O to E. How do I find that guy? Now this is where I said I had a bit of discrepancy in when I was drawing using a marker. So, in reality, if I was drawing this correctly, they should probably be in line with each other. My accuracy now is quite poor there. So I'll go up like that. Now, really it should be in the same point. So I'm going to use that one. It's going up as far as there. So that goes heavy to there. And then it'll also go in as far as 1. And there we go. Okay. So that's actually how you complete that little face there, guys. Okay, that comes over. You don't have to put in any hidden detail inside here because that's where the object has been penetrated. It's like that edge isn't even there anymore. So now that we found that in our elevation, what we need to do now is come down to our plan. So let's find those points in our plan. Okay, working in reverse. So I start with number 1. Have I found that? Yes, I found it up here and I have it found in my plan. There's the next one. As I was saying, I'm using that one. I know I had a bit of inaccuracy here between those two. Should be symmetrical. So that goes all the way along there and it hits on the edge from O down to D. There's O to D. So let's bring it down. And it should end up being the same at the opposite side, I'd imagine. Now there's my point. Right there. So, does 1 connect to that? Yes, it does. So there's that one. And because it's going to be symmetrical, I'll end up doing it at the same side. Save me a little bit of time. So now I've got this one and this one. Now I'm going down as far as where number 3 hits. So how do I find where number 3 hits? Number 3 ended up hitting right here. So I'm going to bring that guy down as well. And it'll be the same with number 2. So that's as far as number 3 goes in. Okay. It seems to be like that there. Okay. Now this is the bit, as I was saying, is important here. 3 then goes into here, which is on the edge from O to D. So let's find that guy. So that'll come across and that'll actually hit there. And it'll come down as far as there. That's my point. So 3 then, because that's where the edge for 3 was, comes in, and I just go like this into that point. Okay, so we can kind of see that there. Now we've got this point found, because that was on the edge from O to D, which is right there, O to D. Now, where does that connect to? It connects on to this point, which is on the edge from O to E. So O to E, let's find the point. It was in the same position up here, so I actually just need to extend that down. That will actually go as a hidden detail line all the way along there until I get to that edge. Okay, and now you can see I'm going to end up coming out as far as number 2. How do I find where number 2 was? Well, remember we did the element line, it went down to here. We found it, there's number 2. And as I said, if you follow down, then this is 2. This is where 2 is in the plan. That's out as far as here. So that guy there then, it's underneath it again. Hidden detail. And then what does 2 connect up to? It connects up to this point here, which I found here already. I determined it was kind of symmetrical. There we go. And there we go. Now, don't forget at the very, very end, we also have an edge from E to D. There's E to D. Can't see it because the object is on top of it. And there you have it, guys. Just have a little quick check of that. Oh yeah, don't forget these edges here. Look, O down to the intersection points. So I should also have put those in. Little things that you'd often forget yourself. Even myself now, I forget them at times. And yeah, that is my drawing. Okay, guys. So that there was the 2011 section B question 1 based on interpenetration of solids or intersecting solids. What we did there was we did the auxiliary view of it here. Now, in regards to what you heavy in, you see, you have to nearly be able to visualize. If you're standing here, what can you see? So that's why I was talking about I could see this face, but I couldn't see this or this. And then in the plan, it's like you're a bird in the sky looking down on top of it. So I can see the edge from 1 going down to 2, down to 3, but from 3 all the way across to 2. So watch here, 3 all the way across to 2. That will be in hidden detail. Just realised I nearly forgot another little bit here. That should be in hidden detail there as well. Going down there like that. You can see how easy it is to forget these little things because I'm talking about the edges going down as far as there to there. Okay, so there you have it, folks. I'm just thinking, was there any other ones, any other lines from what I can visualize there? No, I think that's it, guys. That there is the 2011, as I said, question based on interpenetration. Could have been done probably quicker using planes, but that's a method that a lot of students like and they get used to doing because they're quite used to auxiliaries. Okay, hope you found it helpful, guys. That's the question done.